All right, in 7.8, Polynomial Inequalities, we're going to complete this the same way we did in 6.7 Quadratic Inequalities. There's just going to be more zeros on the number line and more areas for pluses and minuses. Otherwise, it's all the same steps. So just like before, your first step is going to get all terms on the one side so that it's either greater than 0 or less than 0. Then you're going to factor. We're going to make sure all these problems do factor nicely. We're going to find all the zeros or the solutions to each of the factors and place those on a number line in order. We will want to determine the degree and the end behavior of the polynomial like we did at the beginning of the unit. This will help determine whether you have a plus plus on the ends or a minus minus or a plus minus, that sort of thing. Step 5 is to determine the multiplicity of the zero. So if you recall, if we had an odd multiplicity for the zero, that is crossing through, meaning it will change signs. And if you had an even multiplicity, that would mean that it would stay the same sign, like it would touch it and turn right back around. And then the last step was shading the plus or minus intervals depending on if we had greater than for the pluses or less than zeros for the minuses, and then write your solutions in interval notation. So in this first example here, x cubed plus 12x less than 7x, my first step is to get all terms onto one side. I think I meant to make this squared. So subtract the 7x squared. Such that we have less than 0. Then we'll factor it. The first thing I'm going to look for whenever factoring is if there's a GCF. These all divide by x. And then that's a regular trinomial that we can factor. X minus 4, x minus 3 will work. And so my three zeros or solutions would be 0, 4, and 3. So I'll place those three numbers on a number line in order, 0, 3, and 4. Now the multiplicities of each of these zeros are each going to be 1. X to the first, x minus 4 to the first, x minus 3 to the first. So they all have a 1 multiplicity. This tells me that they will all cross through the x-axis if we had to do a full graph on this. In other words, they will all change signs from one interval to the next interval. Since all the multiplicities are 1 for each of these, 1, 1, 1, if you want to find the degree, you can do this in two ways. Either add up all the multiplicities, and that's one way you can find your degree, or look back at the original problem and look for the highest exponent. That will tell you the degree. When your degree is odd, that will tell you that you have opposite end behavior. It'll be a minus plus. And you notice that this is positive here, so we don't have to worry about flipping the signs around. So odds always start down, then up, or minus, then plus. We stated earlier that since these zeros all had odd multiplicities, they must change signs. So since 0 had an odd multiplicity of 1, it was a minus, and we're going to change to a plus. The 0, 3 also has an odd multiplicity, so it will change from a plus to a minus. And then finally, 4 has an odd multiplicity, so it will also change from a minus to a plus, which we already knew because of the end behavior. So this will be a minus plus inequality. See if your inequality should be less than 0 or greater than 0. Because it says less than 0, we're going to shade the negative parts. So this portion and this portion. Since it's not equal to, these will be open circles. And then we just state in interval notation the intervals in which we shaded. So we shaded everywhere left of 0 from negative infinity until 0, parentheses, because it's not equal to. Union to join another interval. And the next one starting at 3, ending at 4, and that's the only negative intervals. And that would be my final solution set here. This next example, do the same thing, get all terms onto one side. So I would subtract 11x squared and subtract the 12. And notice how I put this in standard form in order. There is no GCF at this point. I do see 4 terms, so I would think about by grouping. This one, I guess I could factor out an x squared. That one I could factor out a 4, but they're not going to have common factors after that. So by grouping would not work for this. So the only other way we know how to factor is what we learned from the last couple sections from 7.6, is we have to do the rational root theorem and figure out which one of these possible rational roots, will give me a remainder of 0, telling me that we have a solution and telling me that we have one of the factors. So if you remember how to list possible rational roots, we will take the last number, the first number, list all the factors that would make 12, all the factors that would make 2, and so all my possible rational roots would be all the combinations of 1 over 1, 1 over 2, 2 over 1, 2 over 2, which we know is 1, 3 over 1, 3 over 2, 4 over 1, 4 over 2, which is also 2, 6 over 1, 6 over 2, which is 3, and finally 12 over 1, and 12 over 2, which is 6. So I would plug this into my calculator, the one that is set to 0 like this. Plug that into your y equals calculator, and see if any one of these numbers, remember plus or minus for all of them, would be a possible solution. So just to save some time here, let's say we did that, and we're going to find positive 2 is one of our zeros that we found on our calculator. It would cross the x-axis there, it would equal 0. So if we know one of our factors is going to be 2, then that tells me I can divide this by x minus 2, the factor. So I'm going to do this synthetically. I would put 2 in the corner, the coefficients 2, negative 11, 20, negative 12 up top, do synthetic division. Drop, multiply, add, multiply, add, multiply, add. And there's your remainder of 0, which tells me that this is in fact a solution and that x minus 2 is going to be one of the factors. The other factor is my quotient, 2x squared minus 7x plus 6. From there, since we have a quadratic, we can solve this one of two ways. We can either continue factoring or use quadratic formula. As I mentioned earlier, I'm going to make sure all these inequalities do factor. So we don't have to bother with the quadratic formula. We'll just try to factor this. Because there's a 2 there, this is going to be a trial and error type of problem. So 2x and x. Thinking about 3 and 2, which will work if I do this. Since that will make a minus 4, and this will make a minus 3, creating that minus 7x in the middle. So now this is completely factored. And it looks like that we have x minus 2 and another x minus 2 factors. So whenever you have repeated factors, it's very helpful to rewrite it as the power, so x minus 2 squared. So now my solutions are 2 and 3 halves. And the reason why we only have 2 answers is because 2 is a solution twice, or has a multiplicity of 2. And 3 halves has a multiplicity of 1. So my degree here is 3, since 2 plus 1 makes 3, or look at the original problem, the highest power is 3. So just like before, on my number line, 3 halves comes before 2. Since my degree is 3, this will be odd end behavior. Odd end behavior goes minus at the beginning, plus at the end. Then 3 halves is an odd multiplicity, since it has a power of 1. So that tells me, since it was negative, it must change signs to a positive. Then 2 has a multiplicity of 2, which is even. Even multiplicities, whatever sign it was before, must remain the same sign, and it does do that here. So that's why we have a plus plus. So whenever we have an even multiplicity, not an even 0, but an even multiplicity, the power, the signs will not change from before to after. So this is a minus plus plus inequality. Then we will determine if we are going to shade the positives or shade the negatives. Because it says greater than 0, we're going to shade all the positive sections. And they're going to be closed circles because of the equal to. So we will shade between 3 halves and 2, and we'll also shade everything after 2. Now, because that circle of 2 is closed, we essentially have shaded everything from 3 halves over. So my interval will start at 3 halves. It will go to 2, but it will also equal to and continue past it. So we'll just go all the way to infinity. always parentheses on the infinities. But the 3/2 gets a square bracket because of the closed dot, because of the equal to. And that is how we do polynomial inequalities. There we go. So let's take a look at the homework and point out a few things. First of all, the first, 2 problems are completely factored already. So looking at this, we would have -1 and 3 as my zeros. The multiplicities are 1 and 2, so it tells me we are degree 3. Degree 3 is always minus at the beginning or down, and plus at the end or up. -1 has a multiplicity of 1, which will tell me the signs must change. 3 has a multiplicity of 2, which tells me the signs will not change and stay the same, and they do that. So I can be confident that this is my intervals. It says greater than 0, so I will shade all the positives. It's not equal to, so I will open circle these. And this time the 3 was not shaded, so I will have to write 2 separate intervals, starting at -1 until 3. We stop at 3, we do not include 3, but then everything after 3 is positive. Number 2, those are all odd multiplicities. They will all change signs. It's already factored. Number 3, it's partially factored, but this right here can factor again. So make sure you do that first. So x plus 1 is already there. And then this will factor as x minus 2, x minus 1. So you'll have -1, 1, 2 as your solutions. This is a multiplicity of 1, 1, and 1, so all odd. It also adds up to a degree of 3. Odd degree tells you down, up for your end behavior. Since they're all odd multiplicity, they must all change signs. Minus the plus the minus, and minus the plus. Here we'll shade all the negative parts. Negative infinity to -1, and 1 to 2. After that, just make sure all the terms are on the one side, so 5 and 6 already does that. This one you'll probably have to use your calculator to find one of the zeros. Then you can do your synthetic division to find the other factors to continue factoring it. Excuse me. Make sure for these ones you move everything over to one side. And you guys can skip number 13. If you guys have any questions, let me know.